So here's that take-home test that you got in class. I'm going to do these answers for you, so you can do this weekend. So let's see. Question number 1. We got to remember that's the equation of a circle, and remember that that is the x for the coordinate, the x coordinate of the center. That's the y coordinate of the center, and the r stands for the radius. So since x is 1. We're going to write x minus 1 squared plus y minus a negative 6 turns to positive 6 squared. And then we're going to square the radius. Now what you want to be careful of is that this is the radius. If I tell you this is the diameter, you've got to remember to cut it in half. Okay? So that's that problem. This problem, we want to find the length of the line inside the circle. So this is like that problem you did out of the book. So I drew a sketch of this. We know the radius is 7. So that's 7, that's 7. And I'm just noticing a mistake. This should say y equals 4. That's that line. So let's come up with an equation of the circle. Well, I know that it's centered at the origin, so really you can just have 0 there. We know the radius is 7, so we're going to square it. So we really have this equation here. And we want to find out the x-coordinates, because what we want, isn't what we want this line here, the length of that line segment? And there's a lot of ways we could do this. I'll do it this way because it's consistent with what you did in the book. So the equation of that line is y equals 4. And that'll let us, if we substitute that into the circle equation, that'll tell us the x, and we know the y is 4. But we're looking for those x values, and they aren't where that drawing is. So I'm going to replace y in my equation with 4. That's what y is. So that's going to be x squared equals 16, x squared plus 16 equals 49, so x squared equals 33, because I'm going to subtract, and then I'm going to take the square root, and because I'm taking the square root, I got to worry about plus or minus. And you can crunch that on the calculator, and I can look at this. For this problem specifically, that's negative root 33, that's positive root 33, and how wide is that line? How far apart are those? Well, isn't that 2 times the square root of 33? And that's how far is inside that circle. Okay, a little bit easier problem that you had to do in the book. But I'm going to ask you in the test, it could be one or the other. I don't know which yet. I'll have to make up my mind. So here's this one. We convert these radians to degrees. So when I'm going to convert radians to degrees, I'm going to take my radian measure, which will usually have a pi with it. I better not say that because it won't always have a pi in it. It'll take my radians and multiply by 180 over pi, because that will cancel off the radians. So for this one, pi over 9 times 180 over pi. The pi's cancel. The 9 cancels into the 20 and the 80, and I get 20 degrees. Okay. For this one, we're going to do degrees to radians. You take your degrees and multiply by pi over 180. So for this problem, 900 over 1 times pi over 180. Well, I don't know. I know 9 goes into both of those, which would be 20. That's 100. And then 20 goes in 100 5 times, so that answer is 5 pi. So we got to find an angle between 0 and 360 that is coterminal to that angle. Okay, well, let's see. That's 360 degrees. What's 675 minus 360? 315. So that falls about here. So what angle is coterminal at? I would say 315 degrees. And that's in between the range, in that range, okay? Now how about something that's a negative 23 pi over 6? Well, Negative, I'm going this way. That's 2 pi radians. Since this has a denominator of 6, isn't this 12 pi over 6? So what's 23 pi over 6 minus 12 pi over 6? Well, 23 minus 12 is 11. So that's not quite all the way around again. So that's right there. I know my reference angle is pi over 6. Because that would be another pi over 6 would make it 12 pi over 6. So the coterminal angle in that range would have to be pi over 6. A wheel with a radius 20 rolls along the ground. Rotating 120 degrees. So it starts here. It's going around not quite. Is that about a third? That's about 120 degrees. They want to know what distance did it roll. We want to find that arc length. So when on the board I told you to write down that arc length equals theta times r, but theta has to be in a radian form. So 120 times pi over 180. I can take 60 out of both of those. So 2 pi over 3 times the radius, which is 20. So isn't that 40 pi over 3 and centimeters? And since this, I can't use a calculator, I'm going to leave it that way. Okay, here's a Ferris wheel. It has a radius of 60 feet. So I'm guessing they're telling me that that Ferris wheel looks like this. It has a radius of 60 feet. It turns 1 revolution every 3 minutes. So we want to find the linear velocity. So this is like that problem with the CD that we did out of the book. So let's see. We know 1 rev in 3 minutes. Now, Ferris wheels turn pretty slow. So it isn't like it's going to be a miles per hour. So I'm almost thinking we could do this as feet per minute as a final answer and see how that looks. If it's too big, too small, we can do some conversions. But let's start with that. So I know I want my answer in feet per minutes. I'm given revolutions per minute. So the minutes are okay. I guess I've got to convert my revolutions into feet. Well, in 1 revolution, 1 revolution is the same thing as the circumference. So circumference is going to be 2 times the radius, which is 60, times pi feet in 1 revolution. The revolutions will cancel. I'm also noticing 3 will go into 60 20 times. So I'm thinking the answer is going to be 40 pi feet per minute. And that's certainly an acceptable answer. That's not going to be too big. Okay, now we got to find the exact value. So I'm assuming you're going to have this table in your notes, and that all seniors turn crazy, which tells you what is positive in which quadrant. And then if we think about the Cayley-Green shortcut method of finding the reference angle, that'll help us. Let's see. So what is it? Well, for the first one, 3 pi over 2 is the same thing as 270 degrees. So we know that we're going to be looking at that point there, right? That's 270. 3 pi over 2 radians. Cosine is the same thing as the x value, sine is the y value, so we know this is going to be equal to 0. 4 pi over 3. Now let's see. I know that this is 3 pi over 3 because that's 1 pi radian. So 4 pi over 3 is a little bit further. So that's down in that quadrant. I know the reference angle, because of Kaylee's little shortcut, is going to be pi over 3. So we're looking for cosecant, which is root 2. In this quadrant, we know only tangent and cotangent are positive, so it's going to be a negative root 2. All right, so that's that one. How about the tangent of 5 pi over 6? Let's see. So 5 pi over 6. Well, I know pi radians the same as 6 pi over 6. So 5 pi over 6 is here. It's tangent. I know tangent in that quadrant's negative. I know the reference angle is pi over 6. So I'm looking for tangent. So 1 over root 3. Of course, this isn't rationalized, so let's rationalize it by root 3 over 3. Because remember, 1 over root 3, I'm going to rationalize that. I'm going to multiply by the form of 1, which is root 3 over 3. So 1 over 3, or root 3 over 3, and it's negative. The cosine of 6 pi, well, let's see. That's 2 pi, 4 pi, 6 pi. So that's falling right there. The same thing as those points. We're looking for cosine. Cosine is x. Answer is 1. Negative 5 pi over 6. So negative 6 pi over 6 would be here. So we're not going quite that far. So for sine in that quadrant is negative. Reference angle is pi over 6. We're looking for sine, 1/2. Cosine of 135 degrees. 135 is there. Reference angle is 45. So reference angle is 45. We're looking for cosine. So it's going to be root 2 over 2. But in this quadrant, only the sine and cosecant are negative. Are positive, so that tells me this answer has to be a negative. Cotangent of negative pi over 5, negative 45 degrees. Negative 45 degrees is there. We're looking for cotangent. Cotangent, remember this is cosine. Cotangent's negative. So the reference angle is 45 degrees. It's cotangent, I'm looking at 1. So it's negative 1. Secant of 210. 210 is right about there. That's going to be 210 minus 180. Leaves me a reference angle of 30. All right, so 30. We're looking for secant. I'm seeing 2 root 3 over 3. I know down in this quadrant the cosine is negative. So that's that answer. I'm going to stop this and continue on another video.